The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video: Square root of a number with the two zeros as the lowest digits. Example 96,100. In the previous example 91,809, we got the square root as 303. That means 0 as the second digit of the square root. Let us take an example where we get the square root with 0, but that becomes the lowest digit. Let us take the example 96,100. We had mentioned that for calculating the square root, we have to group the numbers from the right side. Therefore, the first group becomes 0, 0. Second group becomes 61 and the third group becomes 9. For the purpose of calculation, we can consider the groups in order as 9, 61 and 0, 0. Let us set the number 96,100 by leaving 3 columns in the right extreme of the abacus. That is, the lowest digit 0 should be set in the thousands column, 0 in the 10,000s column, and 1 in the column left to it, 6 to the left of 1, and 9 to the left of 6. That means we leave the 3 mandatory columns and the 2 zeros occupy 2 columns which are empty. Take the first group 9 and consider the perfect squares there. 4 and 9 are the perfect squares in 9, and therefore we have to take the highest among the two. Take the square root of 9, which is 3. Set 3 by skipping a column to the left of 9. Now 3 multiplied by 3 is 9. That should be subtracted from 9, which gives the remainder as 6,100. In the next stage, double the number 3 and set that in the extreme left of the abacus. Consider 6 and 6 of 610. As 6 by 6 is 1, the second digit of the square root becomes 1. Now 1 should be set to the right of 6. Now 1 of the square root 31 is multiplied with 61. That should be subtracted from 61. Now the remaining value becomes 0, 0, 0. Though there is no further calculation processes involved, but the remaining 0 should be accounted for in the calculation of the square root. Like our normal procedure, let us take twice the value of the square root we have got so far. That is, 31 becomes 62, which should be set in the extreme left of the abacus. As the remaining value is 0, 0, 0, we simply treat the third digit of the square root as 0, and therefore there is no remainder. That means the square root we get is 310. Another shortcut can also be adapted in finding the square root of such numbers. When you take the first 3 digits of the number, and if it is giving a perfect square root, then if you have 2 zeros in addition to that, you can take one of the zeros and use that as a part of the square root. For example, here in the problem 961 0, 0. The 961 is a perfect square. That is, you get 31. You have two zeros. In such cases, 1 0 from the remainder two zeros can be added with the square root of the first three digits, and then your answer becomes 310. It should also be noted that number having two zeros at the end, that is zeros in the unit and tens column, does not mean that you will get a perfect square always. These differences will be understood by the child with more exercises dealing with numbers which have zeros at the end.